this trigonometry. It will come. Through trigonometry, we can try this. Don't waste time on these 4 sources. Believe in your teacher. At least if you are really don't want to accept this, at least for 3 sources, try it. If you get this 8 years no by trigonometry, okay, one is also correct. I'll take the question now. This is a not a traveling sound wave. It's a displacement as a function of time is telling. I think you recollect so many ideas will be there, no? Let me put that graph. Lot of information will be available. O, A, B, C, D. There's a displacement or why you can write it, any of the thing. And there's a time. Or say y of x, sorry. Not y of t. Any conclusion can we make it? Y of t, if they give what we should do? We'll calculate the excess pressure versus time graph, because what is the relation between delta P equal to? I think, can you remember this? If you know displacement wave, you can calculate the excess pressure wave. See, small basic ideas, because you can't fight with any other thing. We have only this particular thing, that one. Be the bulk modulus, dy by dx. Dy by dx is what, y of x is what I'm giving. Y or yes, anything you. How to decide?
Wave equation we can.
Wave equation.
Yes, sir.
Okay, right, wave equation. Excess pressure is ds. I just made y so that it will flash for you, because s again you'll start thinking some other thing. So therefore I just took this one. Okay, dy by dx. No. What is about the speed of particle? Any relation between speed of particle? Because what is the equation? Y is equal to, we do write like this, no? Y is equal to, let it be sine omega t minus kx. Dy by dt is what? Particle velocity. If I differentiate this, dy by dx, so I'll get minus ak cos omega t minus kx. Okay, fine. So therefore this, I'll divide these two. Dy by dt is what? Particle velocity. And dy by dx is nothing but slope. Let me divide these two. So Vp is equal to omega by k dy by dx, negative sign. What is omega by k? Should be speed of the wave. The same set of formulas what you studied for traveling wave on a string, Same thing for sound wave also. So with this, now you know the wave is choose the correct option. So it's telling along positive x direction. So the wave is moving along positive x direction. So you come with sign. So let this be vector. No, if you get velocity of particle along the wave, since wave is moving along positive x direction. So if I can say the wave is moving towards right or towards left, it is like this. So look for the slope. So what about the particle A and C? The particle A and C, they are at rest, no? Slope at B is maximum and negative slope. So it will be positive slope. So slope will be negative. So in what direction the particle B will be moving? Okay, first I'll come with option A. Particle located at C has zero velocity. Will I agree? What is the slope at C? Don't think that the particle is vibrating here. This particular particle A, where it is at extreme point. And at extreme point, what is the state of it? Should be at rest. So therefore, it is having maximum amplitude. Displacement wave. Think in terms of displacement wave. So this will be A and C are at rest. I have to write conclusion. Because we do have everything. Let me write all the conclusions to be easy for us. No, which all particles are at rest? A and C are at rest. Sir, is it at a right extreme or left extreme? Anybody, can you say anything about from mean position? It is on right side, no? Plus say it is amplitude is having. What about particle C? It is on the left side of mean position and at extreme point. So it is at left extreme at that instant. This is okay. Now, after this, okay, let's come for A and C. Particle located D as its velocity in the negative direction. Okay, it's asking now D, B, and O will come for this one. So what is the slope at this point? Slope is negative. Native of native will be positive. So the B will be moving in the direction of wave. What about D? Slope here will be positive. Will be moving opposite. So how the motion of particle? The B will be moving towards right. Moving along positive direction. D moving along negative direction. The pressure rate, okay, these are both the things. Even O also, O and D. Let's see. Positive displacement means, what does it mean? What do you mean by positive displacement? Because you measure y along x-axis, no? It is. No, at that instant, we are plotting at that instant, no? Say from mean position, it is at right, it is on the extreme point. So how you measure y? Y will be towards right. Okay, yeah. Okay, there's about nothing. Okay, now let's come for pressure. How to say particle? How to say pressure one? How to check about pressure one? Now, if a particle is vibrating, if a sound wave is propagating, where the pressure and kinetic energy both will be maximum. Anybody wants to answer?
Energy will be maximum at mean positions.
Both, huh?
Pressure should be maximum at extreme position.
No. Recollect. It's not, see, though it's SHM, but in wave propagation, I think we made some conclusions, no? Otherwise, how energy transfer will occur? Both should be maximum at mean and at extreme, both should be zero, even for sound wave also. Okay? Like what happened in traveling wave, the similar thing for sound wave also. When a sound wave propagates, then the strain energy, rather than say potential energy, better called strain energy. The strain energy and the kinetic energy both will be maximum at mean and both will be zero at extreme. Then only the transfer of energy can occur. Though it's SHM. So therefore, B and D, the pressure rate, now let's come for B and D. How to check, is it a, and at extreme point what happened? It should be the normal pressure, means no compression or no. So I think what is one more thing I'm unable to, rarefaction, compression or rarefaction. At extreme points, what happened? Compression, rarefaction will not be there. Only at mean position, only compression, rarefaction. Kinetic energy and the pressure energy will be also like the strain energy will be maximum at mean position. So what do you mean by mean y equal to 0? So therefore, shall we put like what should be the pressure at A and C should be equal to P naught, normal atmospheric pressure. B and D, what happened? It will be excess pressure. How to check which is the compression rarefaction? Anybody wants to answer?
By dy by dx slope.
A and C are at rest and pressure A and C, pressure at pressure, will write it. PA, I'll write it. I think this will be pressure at A and C equal to P naught. Okay, now pressure at, now, okay, we know at mean position, kinetic energy will be maximum. Even the strain energy will be maximum, or potential you can say maximum, that one. How to check which is compression rarefaction? We have this formula. If excess pressure positive, what do you mean by that? Compression. Excess pressure negative, rarefaction. So look at the slope. So therefore, what we can write B as slope negative, negative. So B should be compression. What about D? D should be rarefaction. Is it only B rarefaction or any other thing? Now one more. Compression will be there only at one point or several points? Several points here. Again, you look at the slope. This is the maximum compression, let me say. So compression decreases and it becomes zero. Next, what do we get? Rarefaction. So therefore, this is a maximum compression. When you move from A to B, what will happen to compression? Compression increases, maximum compression. What about here? Compression decreases, maximum compression decreases, becomes zero. Then rarefaction. So if you want to write, what you should say from A, B, C is what? Compression. Next, what you get? C, D, E will be rarefaction. D will be maximum rarefaction. B will be maximum compression. Let me dump that also. So A, B, C is compression. C, what happen if you want, you can avoid. So from A to B means A actually you should not take it because C cannot be compression and rarefaction. So there no compression, no rarefaction. So I don't have any other thing. No. So therefore from A to C, between A to C is what? Compression. Okay, this, I think this will be more. Okay, similarly, I have to go for. It's a small idea based because we don't have any. There's a small basics formulas what happen that should be applied properly. We'll extend further. Okay, call this as. No. C to E will be rarefaction. Okay, I'll go to our next problem. I'll scroll down. How do particles will vibrate? Along x-axis. So I think that's a very important thing. If you say particle vibrate along y-axis, gone. Particles vibrate only along x-axis. So